Recall that we prefer to control for risk within the alpha factors, rather than waiting for the risk model optimizer to do it completely for us. This is why we make the alpha vector dollar neutral and often also sector neutral. The reason we wish to control for risk early on within the alpha vector itself is so that after the optimization, the portfolio weights are not too different from the original alpha vector. It's natural for you to wonder, why is it an issue if the portfolio weights are nothing like the original alpha vector? To understand this, remember that we're evaluating each alpha factor in isolation of other alpha factors. We evaluate the alpha factor to see if it may be a good candidate to help improve the performance of a portfolio. If, after optimization, the risk model significantly changes the weights for stocks so that they no longer follow the weights chosen by the alpha vector, then we can't expect the performance of the alpha to carry over into the portfolio. As an example, imagine if an alpha vector gives most positive weight to stock ABC. But after the risk model neutralizes various common risks, the final portfolio weights end up shorting stock ABC. Then the signal from the alpha vector, which essentially says buy stock ABC, is no longer being followed. This means that the performance that we originally hoped to gain from using this alpha vector may not carry over or transfer to the portfolio itself. Remember that the alpha vector is an expression of expected returns. And if the portfolio weights after every optimization are very different from the original alpha factors, then the portfolio itself may not be capturing the information expressed by those alpha factors. To see how closely the optimized portfolio weights still match the original alpha vector, we can calculate something called the transfer coefficient. The transfer coefficient measures how closely the optimized portfolio weights match the original alpha vector. To get the transfer coefficient, we need to use portfolio optimization that includes a risk factor model. We will learn about the portfolio optimization step in a later lesson. For now, let's just assume that we have a portfolio optimizer that outputs portfolio weights. We start with our alpha vector, pass it through the portfolio optimization, and get portfolio weights. The transfer coefficient is the correlation between the alpha vector and the resulting portfolio weights. A high transfer coefficient is a good sign that the alpha vector has survived the portfolio optimizer's risk neutralization. The transfer coefficient is also a useful measure for another desired attribute of an alpha factor: independence from risk factors. Ideally, we would like to find alpha factors that are independent of the common risk factors. If alpha factors were too correlated with the risk factors, then they would also be neutralized by the risk model.